Hi, hello and assalamualaikum. My name is Nur Alia Sofia binti Zulkifli. Meet my amazing teammates Nur Wardinatul Akmal binti Jamaluddin and Nur Hanisah binti Nur Hamidi. We are from class RAS 1202F and we were going to present a topic about related rates of change. But before we begin our presentation, we would like to express our special gratitude to our beloved lecturer, Madam Nurzila binti Muhammad Sharif, who gave us this opportunity to do this project on the topic related rates of change problem. We also sincerely thank you to Madam Nurzila, lecturer of Calculus 1, for all the guidance and willingness to help us completing this assignment.
Okay, now we are going to look at the application of rates of change. Alright, so in the differential calculus, related rates problems involve two or more variables that change at the same time, possibly at a different rate. The rate of change is usually with respect to time. In the related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily calculated.
So this is the problem statement, which is cylinder. So this is example question. As you can see at the right, we can see a figure of cylinder. You can see there's radius, the height, and the given information says the height is equals to radius plus 2. So let's see the question. An ice cube in the shape of a cylinder is melting at a constant rate of 2 centimeter cube per second, as shown in the figure. Question A. Find the surface area of the ice cube in terms of R. Question B. Find the volume of the ice cube in terms of R. And the last one is C. Find the rate of change of the surface area of the ice cube when the radius is 4 centimeters.
So now we are going to look at the problem solution for the question A. So in this question, we are going to find the surface area of the ice cube in terms of R. Since this question is about the cylinder, we will use the formula of surface area for the cylinder, which is 2 pi r squared plus 2 pi r h. And then we need to replace the h with the value that was given in the question, which is r plus 2. And then after expand it, we will get 2 pi r squared plus 2 pi r squared plus 4 pi r. And for the final answer, we will get 4 pi r squared plus 4 pi r.
Next, let's move on to problem solution question B. For question B, we need to find the volume of ice cube in terms of R. For the solution, in order to determine the volume of the ice cube, we need to use the volume formula of cylinder, which is V equal to pi r square h. To determine the volume in terms of R, we need to substitute the h value. From the figure, we know that the h value is r plus 2. So, the final answer we got is pi r cubed plus 2 pi r squared.
So the last question is question C. So this is the problem solution. The question C, find the rate of change of the surface area of the ice cube when the radius is 4 centimeters. So first we need to write down the given information. The volume is negative 2 centimeters cube per second. So you might ask, why is it negative? It is because the negative is inferred from inclusion of the word melting in the problem. So the question asks, find the rate of change of the surface area. So it means dA over dt. So we want to find the dA over dt when the radius is 4 centimeters. So let's say the dA over dt, we try to separate into two parts. So dA, and here is dt. Next, the volume the value I'm going to substitute here is depend on the information that we have. So we already have dv over dt, which is -2. So substitute dv on both top right and bottom left. In this case, there is no way to get dA over dv, so dA over dv needs to be separated again. So this dA and here is dv, we need to multiply it with dv over dt. Next, we substitute dr with respect of radius. This is because the formula area of the cylinder has the variable of r. From the answer of the question A, it's 4 pi r squared plus 4 pi r. So we need to differentiate it. A respect to r, which answer is A 8 pi r plus 4 pi. So from the answer of question B, volume is pi r cubed plus 2 pi r squared. So differentiate it. Volume over radius equals to 3 pi r squared plus 4 pi r. So we need to substitute the differentiations in the next one. So do dA over dv multiplied with dr over dt. So what we have here is dv over dr, but the requested is dr over dv. So we need to do 1 over 3 pi r squared plus 4 pi r. So finally multiply with dv over dt, which equals to -2. The answer will be -16 pi r minus 8 pi over 3 pi r squared plus 4 pi r. So when the r is equals to 4, substitute it to the answer we got before. And the final answer will be -9 over 8 centimeters squared per second. Yes.
So, in conclusion, if we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. That's all for our presentation. Thank you.